Last episode, we said the model's weights are frozen after shipping. So how does it handle your conversation? Where does it remember what you just said? The answer is the context window. And it's the most useful thing you can understand about a chat model. The context window is the model's working memory for a single conversation. Everything the model can see right now lives inside it. Your messages, the model's previous replies, any system instructions the product added on your behalf. And it's measured in tokens, those chunks we covered in episode 2, not words. Here's how it actually works. Each time you send a message, the model needs the relevant conversation so far inside its context. The product may resend it, reference stored conversation state, or use caching behind the scenes. But from the model's point of view, it can only respond to what is inside the context window right now. That sounds wasteful. It is, but it's also what makes the model feel coherent. Now, every model has a maximum context size. Modern frontier models commonly support context windows from tens of thousands up to 1 million tokens. The exact number varies by model, product, and setup, and changes often. What happens when your chat grows past the limit? The product has to decide. Some apps drop the earliest messages. Some summarize older turns and keep the summary. Some refuse to continue. From your seat, it looks like the model forgets what you said earlier, and now you know why. One more thing. A huge context window does not mean perfect recall. The model may technically have access to a long transcript, but still pay more attention to recent or clearly repeated information. So the safest instructions aren't just placed early. They're clear, short, and repeated when they matter. This is where memory features come in. Some products store memories between sessions. Facts about you, the model can pull in next time. But those memories live outside the context window. They're a product layer system, separate from the model's frozen weights. The product looks up relevant memories and pastes them into the conversation as text, back inside the context window, before sending it to the model. 3 practical consequences. First, long conversations drift. Once the early turns scroll out of context, the model can't refer to them. If you set up rules in turn 1, and your chat is hundreds of turns long, those rules may be gone by the time you ask. Second, pasting huge documents costs context budget. A 50,000 token PDF eats half of a 100K context window. The model can read it, but it has less room to think alongside it. Third, context limits explain why some answers feel shallow. The model isn't being lazy. It might just be running out of room to reason in. So here's the picture. The context window is a fixed size buffer. Your conversation lives inside it. Every reply depends on what's in that buffer. Once full, something gets dropped or compressed. The model's immediate memory is whatever happens to be in that buffer right now. To recap, context window is working memory, measured in tokens. The whole conversation needs to fit inside it. There's a hard size limit per model and product. Bigger is not the same as perfect recall. And memory features sit outside the model. They paste into the buffer when relevant. Next episode. You now know 3 things about the model. It predicts tokens. Its weights are frozen. Its context is finite. Put those together, and you can understand its most famous failure mode. That's hallucinations. If this was useful, subscribe. It tells me to keep making them. See you next episode.